Hi guys! Welcome to a 18.3 lesson on triangle proportionality theorem. I'm not gonna lie, it's not fun and it's kind of hard, but we're gonna do it, okay? So we're gonna prove the triangle proportionality theorem and its converse, and then we're going to apply it, okay? So let's take a look. We have Clarissa, and she is needing to find the distance across a lake this time in a national park. She locates the points A, B, C, D, E, and takes the measurements shown. She thinks she can use similar triangles to find the distance of the lake. Okay, so let's see if she can find it. Number one, if I know MR is parallel to ST in the figure below, explain why triangle MAR is similar to triangle SAT. Okay, so first off, the first thing I know is I know angle A is congruent to angle A because I have a triangle on top of a triangle. Okay, so they're sharing that angle A. It's overlapping. So I'm going to say angle A is congruent to angle A. That is called the reflexive property because it's reflexive. Property. All right, so that gives me one angle. I'm probably going to prove angle right here. So if these are parallel, I know I have corresponding angles, and you get to pick whatever angle you want. I'm going to pick angle S and angle AMR just because I want to. So angle S is congruent to, I can't just say angle M because I don't know which one we're talking about, so I'd say AMR, angle AMR. The reason they're equal is because they're corresponding angles. Corresponding angles are congruent. So because I know angle A is congruent to angle A, and I know angle AMR is congruent to angle S, I now have angle. So they are similar because of angle similarity. Okay, so that's kind of an informal proof of why I know my two triangles are similar. Okay, all right, so if they're similar, I now can figure out missing pieces of them. So knowing that corresponding sides of similar triangles are proportional, complete their proportion. So let's color code this. It says AM, which is up here in green, over AS. Now notice AS is the whole thing. So I have part over whole equals AR, which is my other part, over the whole, which is A to T. Okay? So my proportion would be A to T. Okay? So it kind of helps you out if you ask yourself part over whole equals part over whole. I'm going to go ahead and write that. Part over whole. Okay? Now, knowing that information, let's solve a problem. So it says AM is 12, MS is 9, and AR is 15. So AM is 12. Scroll up and down. MS is 9. AR is 15. And I'm trying to find RT. Okay? All right, so I'm going to do part over whole equals part over whole. I'm going to follow this proportion up here. So the biggest thing is my part is my 12, and this 9 doesn't come in handy until I need to know the whole entire thing. So let's start off with part, which was 12, over the whole entire thing, which is A to S. So if I want to find the whole thing, I have to add my two side lengths together. So 12 and 9 is going to be 21. So part over whole equals my part, which was 15, over my whole. And this is where it gets tricky because the whole entire thing, I have to add these two together. So it's going to be 15 plus x. Okay, so my whole entire thing is 15 plus x. And I solve it. Okay, so I'm going to cross multiply. 21 times 15, 315, I think. me double check that. 21 times 15. Yep. 315 equals 12 times all of that. So 12 times all of that. Okay? Distribute. 12 times 15. 180. So 315 equals 180 plus 12 times x is 12x. Subtract 180 on both sides. $135 equals 12x divided by 12. X equals 11.25. Okay, and so that would be the length of RT. So RT is 11.25 centimeters. That's my distance. Okay, so to review that, I have two triangles that are similar, and then they gave me a part and a part and a part. I'm looking for a part. And so to do the similarity proportion, you would do part over the whole thing equals part over the whole thing. To find the whole thing, you have to add your parts up. And if you have a variable in the part, you're going to have to put a plus sign with the variable. Okay? Which gave us this equation, and I cross multiplied, and I got 11.25. Okay? So I'm going to give y'all a problem. So I would either redraw this picture for us, or you can erase your work up here. But I'm going to go ahead and create it for you again. So A is at the top, S and T, with a line, M and R. Okay, so here is your picture for number 4. It's the same picture above, I just redrew it to help us out. I want you to solve for AM. Okay, so again, do the similar thing, part over whole equals part over whole, and we'll go over the answers and check your work. So press pause and try number 4 on your own. Take a look at this picture. So the bottom part is 8, top part was 25, bottom right part was 10, and then top left part was x. So I did the same proportion of my part over my whole. So I had x over x plus 8 equals my part 25 over my whole of 35. Okay. This one was a little bit tricky because you had two variables. So you had to do x times 35 and get 35x, and then 25 times x plus 8. Distribute to get 25x plus 200, and in this case we had to get our variables to the left side, and so subtract 25x, and you ultimately get 20, and so AM is going to be 20 units long. Okay, so that's an example of how we can use similar triangles to set up a proportion and solve for a missing side. Okay, so now that's a lot of work, right? So in the math way, we like to show you the long way and then show you a shortcut. Okay, so we're actually going to prove a shortcut that's going to help us out. So let's take a look at that. I'm not going to lie, it's a terrible proof. It's very long. It's the entire page, okay? So this is called the Triangle Proportionality Theorem. Okay, so the Triangle Proportionality Theorem says that if a line is parallel to the side of a triangle intersecting the other two sides, then it divides it proportionally. Proportionally means that B over A equals C over D, and that would have been a whole lot less work for us. So given that RM is parallel to PE, we are going to prove that B over A is equal to C over D, aka proportionality. So let's do this. If you want to press pause and try this on your own, feel free, but it's kind of tricky. So first off, the proof part goes bottom left, so let's go ahead and write that. Oh my goodness, number 11, go ahead and rewrite your proof, that B over A is equal to C over D. Okay, now let's work through this. So, given I have triangle pi and triangle rim with RM parallel to PE, because that is given. Okay, now if I have parallel lines cut by a transversal, I know corresponding angles are congruent. Okay, so an example of corresponding angles would be IRM. So this angle is congruent to IPE. Okay, you could have also said IMR, or you could have said IEP. So you just got to pick a pair of corresponding angles. I picked RMP. Okay. Then, here is where it gets a little tricky. So, I need to prove another angle. You could do two ways right here. We could say angle I is equal to angle I, because that's the reflexive property, because I have an overlapping triangle. Or we could have used our other corresponding angle and said IMR, because this angle was congruent to IEP. Okay. Regardless, I'm trying to find two angles that are congruent so I can prove my triangles are similar. So I would probably go with this one, angle I is congruent to angle I, because the reflexive property, just because I think it's a little bit easier. Okay, so I have an angle and an angle. That means I can prove two triangles are similar. So what matched up with pi would be rim. So I have angle rim, or triangle rim is congruent or similar to triangle pi. The reason they are similar is going to be the angle-angle similarity theorem. Okay, so all I've done is proven that my two triangles are similar. Okay, all right. If two triangles are similar, we kind of just did a problem. This says B over A plus B equals C over C plus D. So B is the part over A plus B is the whole. So part over the whole equals the part over the whole. Remember, to get the whole, you have to add them together. So the reason the part over the whole equals the part over the whole is the corresponding sides of similar triangles are proportional. This is such a fun proof. Okay. If you want to go back to algebra and solve this, you would get a common denominator, multiply all this jazz craziness that they don't even want you to do it. This is going to cancel out, and this is going to cancel out, and it just leaves you with B parentheses C plus D equals B plus A, drop C down. Okay, we're not going to talk about that. That's crazy algebra. Okay, then it says yada yada yada. Hey, distribute. Okay, so I can distribute B times C is BC, B times D is BD, and then B times C is BC, A times C is AC. Okay, so do not worry about any of this stuff. If you're with me on number 8, we're good. Okay, so now what happened from 8 to 9? This dropped down, but the BC's went away because you can subtract BC from both sides and cancel it out, which would be the subtraction property of equality. Okay, then they divided by A and D, which would be the division property of equality. And then, not gonna lie, I don't know what this means, but that's the final answer. Property of the multiplicative identity. Okay, so this is a very long proof that allows us to use our shortcut. Okay, and so all the shortcut is saying is that B over A equals C over D. Okay, so let me connect that for you guys. So I'm going to go back to the problem that we just did. Okay, this was a crazy long problem. Now my shortcut tells me I don't have to do part over whole equals part over whole. I can just do part over part equals part over part. So let's do that and see if it works out. I'm going to do it in green. So I'd say part over part, so x over 8 equals part over part 25 over 10. Okay, now if this works out, I should get 20. So I'm going to multiply 8 and 25. 8 times 25. 200 divided by 10 is 20. Okay, so that's just a shortcut for us. That proof allows us to do a shortcut. Okay, so if you like this way, you can. If you like the shortcut, you can. It's up to you. So you can do part over whole equals part over whole, or you can say part over part, part over part. Up to you. But that is the triangle proportionality theorem. Okay. All right. Let's look at a problem now. So now we can use the theorem to solve a problem from the beginning of the lesson. We had Clarissa was trying to find the distance across the lake. What is the distance between D and A? Okay. So that's similar to what I just did. So I have part and a part and a part and a part, and I can use my shortcut because it's the size of the triangle. So I'm going to say part over part. So let's say 27.5 over the other part you get to pick. I'm going to go from left to right. So 27.5 over 29 equals, so part over part equals part. I got to come back to 54 over x. And then that is a whole lot faster problem than it would have been. Okay, so I'm going to multiply 29 and 54 to get 1,566 equals 27.5x. Last step is to divide by 27.5 to get a crazy long decimal, and that is okay because that's our answer. So x is going to be, let's round it to the nearest tenth, 56.9 kilometers. So that is how long it's going to take her to get across the lake. 59.9 kilometers long. That's a 56. Whoops! Okay. So that is how you can use the triangle proportionality theorem. It tells you that if a line is parallel to another side of a triangle, then it's going to split your sides proportionally, allowing you to do part over part equals part over part. Okay? All right, so the converse of the triangle proportionality theorem, remember converse is just flipped. So I'm going to flip the ordering of this. So instead of if this part, I'm going to put the proportionality part first. So if a line divides two sides proportionally, then it is parallel. Okay? So again, the triangle proportionality theorem, I copied this from the previous page. If a line is parallel to the side of a triangle intersecting the other two sides, if you have two parallel lines, then the lines are going to divide them proportionally. The reverse of that is if a line divides two sides of a triangle proportionally, then they are parallel. Okay? And we're going to skip number 8 because I don't want to write a convincing argument right now. Okay? All right. So that's going to be all for part 1. You're going to turn into part 2 to practice. Okay? So go ahead, press pause, and watch part 2.